Test, test, test. Hello, testing, testing. Okay, well, it's a bit after 8, so I'll just get started. Hello, I'm Carlos. I understand there are other Carloses here that are also presenting. I am not one of those famous Carloses, so. First, a little bit background about myself. I come from the field of mechanical drafting and design, mostly engine parts, architectural fixtures, and things like that. I do the actual modeling parts and building of the drawings that be sent out to manufacturing. I wasn't finding the work that I was looking for. My friend said, hey, try this. And I just finished up 3 years at White Hat Security. So an overview of what I'm going to be doing today. First, a background on how the filter bypass was found, an explanation of what's going on with the process of the bypass as a reminder that client-side security practices and security measures may not always be a great thing. The process for anybody who works in vulnerability assessment, red teaming, penetration testing, to add this process to your toolkit. Demos, of course. Talking a bit about content security policy and how it relates to Internet Explorer. And finally, finishing up with some endnotes. So, just over a year ago, I was working on a vulnerability assessment of a website, was going back over the website in various browsers to see if there's any sort of browser-specific functionality that would appear. Maybe there's something that only shows up when the Chrome user agent is sent, or maybe there's some sort of weird ActiveX thing that only shows up when Internet Explorer is used. So I'm going back over the website in various browsers to see, is there anything that's browser-specific? So early in the assessment, I found a somewhat interesting cross-site scripting vulnerability, where I got my injection to reflect to the page. However, before that injection would execute, there was a block of JavaScript further up the page that would check to see, hey, is this page that I'm landing in being part of sourced in from an iframe from some other page? And if that was not the case, what happened is that the JavaScript would redirect back to that parent page with the iframe, reload the vulnerable page, but without the injection itself. However, the page that's in the iframe was defined by a parameter in the URL. So I could have my injection in the URL landing in the iframe definition, which would then pull in the vulnerable page with the reflection and pop my alert box. So I'd initially found this in Firefox. Again, I was looking around for any sort of browser-specific functionality, didn't find anything. I was working in Internet Explorer and decided that, hey, this thing looks a little interesting. I'll poke at it, just for fun. So as part of a standard cross-site scripting training we get at White Hat, in attribute spaces, we learned that the browsers will automatically decode hexadecimal entities. So as part of my just trying to be clever and not have an injection that looked like script alert went script, I encoded a couple characters so that they would land in the iframe definition as hexadecimal entities, which would then be automatically decoded by the browser for the secondary request to the vulnerable page. And I got an alert box. I was not expecting that. My first thought was I had something wrong. Maybe there was some setting I turned on or turned off somewhere. So I'm going back over the Internet Explorer settings, everything, make sure everything's set to the defaults. Maybe the virtual machine I was working on just started up weird. So just restarted the virtual machine, and no, it still popped. And restarted the computer, no, it still popped. And finally I showed it to my coworker, say, hey, am I just being completely stupid here? Am I overlooking something? Because no, it still pops. So I sent a report to management, and because it's late on a Friday, I went home for the weekend. So over that weekend, I've built some deliberately vulnerable PHP code that recreated that bypass and reported it to Microsoft on that Monday. And after roughly a month of emails, some emails going back and forth, Microsoft has decided no fix. So what's going on? Yes. No fix means there is not a fix now, and there will not be a fix for this in any time in the future, to the best of my knowledge. So this is vulnerable. It has been vulnerable for at least a year, and in all honesty, I'm probably not the first one who discovered this. So the filter in Internet Explorer has a trust model that can be abused. The filter decides which requests it's going to subject to cross-site scripting testing and which ones it's just going to let through. And we can abuse this trust model to bypass the filter. So what's being done is a primary injection is being made onto the page somewhere in the domain. That primary injection does not cause an immediate JavaScript code execution. The primary request is subject to the filter. The secondary request is made in the same domain with data from that primary request. The secondary request does cause JavaScript code execution, and that secondary request is trusted by the filter and is not checked. So the primary request goes through, the filter says, hey, this thing looks good, I'm not going to bother to check anything that comes from as a result of it afterwards. So for processing, for what you're looking for in terms of assessing websites, you're looking for places where you can inject data that can be then reintroduced back to the same domain through some other method. So it's iframes, frames, form submissions, landing in href attributes, landing in JavaScript redirects, or in any place on the page where you can get your anchor tags in and create your own links onto the page. So things to use. In terms of landing, it really depends on what the context is that you land in. So often in attribute spaces, you can use hexadecimal encodings, which are part of the HTML 4.0 specification back in 1998, which started as ampersand hash x and some alphanumeric hexadecimal reference to a character followed by semicolon. Decimal encodings. Decimal encodings are part of the HTML 2.0 specification. It's back in 1995. That's ampersand hash, a numeric reference to some character and a semicolon. Named entity encodings. So that's, again, part of the HTML 2.0 specification back in 1995, where it's an ampersand and then some letter reference to a character and a semicolon. And finally, just ordinary URL, URI encodings can also be used. Part of RFC 1630 back in 1994, where it's a percent and a hexadecimal reference to a character. So these are all methods depending on how you land. Often all of these can be used if you land in attribute space, if you land in JavaScript space. The URL, URI encodings can be especially useful as well. In terms of that initial request onto the page, the filter does not like periods at all. If you're doing this on your own and you're testing stuff out, and if you're getting the Internet Explorer has modified this page to prevent cross-site scripting error message, it's probably a period that landed in your initial request. It also obviously does not like you injecting form, frame, or iframe tags. Sometimes the filter will let you pass through parentheses, square brackets, curly brackets, and occasionally the word style in terms of an attribute. Demos. So I have a website up, the deliberately vulnerable website. So I'll skip over the iframe for now, but this is the oh, before I go any further, I almost forgot. We have our internet or security is set at the default level, and our cross-site scripting filter is enabled. And this is Internet Explorer 11 on Windows 8.1, the latest version updated on Tuesday. So we have a page where injection lands on the page, and then we can then induce a secondary request onto the same domain where it lands. We can inject our HTML tags, which are then rendered on the page as well. So we have a primary injection that lands such that some characters are hexadecimal encoded on the page. The browser automatically decodes hexadecimal characters in attribute space so that when the secondary request onto the same domain is made, our script lands and is executed. And looking at our intercepting proxy, our primary request has characters that are landing hexadecimal encoded, and our secondary request is trusted. It's script source equals external JavaScript file close script. And let's see. That was hexadecimal encodings. You can also use decimal encodings, where it's ampersand, hash, numeric character reference to some character that you want. And again, the secondary request onto the same domain is not filtered. So our primary request, characters land decimal encoded. Our secondary request, script, source equals external JavaScript file, close script, lands on the page and is not filtered by the cross-site scripting filter. So this is the iframe reference that I made. It's basically the same functionality that I initially found this bypass on. So we have this page where there's something in the URL that defines what page is being sourced into this iframe. And on this page 3, we have our injection that lands. And again, we can get our HTML tags in, they render, and the text is changed. So our injection lands on the parent page, lands the iframe at definition. The characters are hexadecimal encoded. The secondary request is automatically made by the browser without user interaction to the secondary page, where injection lands and is executed by the browser. Again, in our intercepting proxy, our primary request, the injection lands, characters hexadecimal encoded. Our secondary request, script, source equals external JavaScript file, close script, lands, and it's being executed by the browser. Okay, I'll just one more with the iframe. Yeah. In this instance, characters are landing such that they are simply URL encoded. The browser doesn't bother encoding them again for the secondary request. However, it passes the first check because when it lands, there's no way that percent blah, 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 blah will actually execute JavaScript in that context. The secondary request is made. Here's the primary request. Some characters, they're double URL encoded so that they land single URL encoded. And then the secondary request, script, source equals external JavaScript file, close script, which lands, and again, is executed by the browser. So, oftentimes, the only thing you'll get is you'll be able to get tags onto the page itself. You won't find some functionality that will let you create that secondary request by itself. So you can actually make your own. So again, we have a vulnerable parameter that lands on the page. It's rendered. However, our injection, I'm not sure if it's visible, but there at the bottom, there's our Internet Explorer has modified this page to prevent cross-site scripting. So earlier I had mentioned that sometimes you can get the word style in. Oops. So with the same page, I've now injected a division element onto the page with the style that says cover the entire page with this thing, and hey, the page that you want is really on this link right here. So you click that link, goes back to the very same page, and our injection is executed. So again, in the intercepting proxy, our primary request, it's a bit long just to get in all the CSS. Lands on the page, and here's our division element, the style, and then a link back to the very same page. Some characters in this case are decimal encoded, and then our secondary request, script source equals external JavaScript file, close script, that lands, and it is executed by the browser. Let's see, I'm just going to go over one more demo. So every so often you'll run into a page that will reflect your injection exactly how it is made. So if your injection is URL encoded or whatnot, it will land as URL encoded. So there's actually this can be bypassed as well. So on this page there's a link, and I'm not sure if you can see at the bottom there. It's a link back to the same page. And we inject something at the end of the URL. It lands on the page exactly as it appears. So our injection URL encoded lands exactly as it is URL encoded as well on the page. So luckily, Internet Explorer does not automatically URL encode some dangerous characters. So we can use a combination of named entities and just regular characters on the page to have an injection that lands. So this injection first closes out that link, then creates a link back to itself with characters. They are named entity encodings. In this specific case, hexadecimal and decimal encodings would not work because they require the hash character, which would be part of the URL scheme. We'll just say, hey, ignore everything after this in terms of sending it off to the server. So the user sees the link, clicks the link, the page loads with your cross-site scripting. So again, in our intercepting proxy, first request, because Internet Explorer does not URL encode dangerous characters, our response lands, closes out the link, starts up a new link, and then our secondary request, script source equals external JavaScript file, close script, lands on the page and is executed. So, content security policy. Content security policy is an extra header as part of the HTTP response headers that say, hey, if you're on this page, only load sources from this specific domain or this specific domain. Do not load resources from anywhere else but these specific domains. So potentially this could mean there's no more cross-site scripting. If you have or no more reflective cross-site scripting, if you're stored somehow, maybe gets by, but so, however, if it's done incorrectly, it could also be just as bad. However, only Internet Explorer 10 and 11 have any support for content security policy. So anyone who has systems that run Windows XP, stuck in Internet Explorer 8 at best, or if you have some sort of legacy application that can go up to Internet Explorer 9 only. And even then, the content security policy support in Internet Explorer 10.11 is limited. It also uses a different header from the official header at the moment. It uses X content security policy instead of the official content security policy header. So it leads us to the question, does content security policy even work in this matter? So let's reload the iframe page and see in the intercepting proxy, let's see, we have this content security policy and X content security policy. Let me preface by saying that it's entirely possible that I got the actual context and how to write this wrong, but I went online and said, how do I set everything to self? So this should be saying content security policy, only load things from my domain that I have set up to be deliberately vulnerable, not the external JavaScript file, which I'm going to try to inject. I could have gotten this wrong, and having said that, you probably understand what's about to happen. So content security policy does not seem to help at all in this matter. So again, look at our intercepting proxy. Our primary request to the page with our, I included both headers just in case there's something weird going on. Our injection lands, it does not cause an immediate JavaScript code execution. Make our secondary request, script source equals external JavaScript file, close script. This page where it lands also has the content security policy headers. It still lands, it still executes by the browser. So content security policy on Internet Explorer does not seem to be functional. So again, I'll just go over a couple other ones. This is that same vulnerable page where we land, we inject the division element saying, hey, you want to go here. And the filter does not bother to check the second request. Jump down here to the JavaScript redirect request. So what's happening in this is that your injection lands in a JavaScript redirect where it says go to this other page over here. And let me just copy this since I only have a limited amount of time. Too slow. So, did I mess that up as well? Okay, so on this page we have our injection that lands in the JavaScript redirect. Goes on to the secondary page where it lands again. Our HTML is displayed. So in JavaScript space, as part of URLs, you can just have a URL encoded characters. So our injection lands URL encoded. We go on to the second page where our injection lands is executed. So again, looking at our intercepting proxy, our request lands in a JavaScript space where it's URL encoded. Our secondary request is made onto the same domain. Script source equals external JavaScript file, close script. It lands. And is executed by the browser. Again, content security policy is not an issue in this case. All right, content security policy. So I was actually given two different reasons by Microsoft why this is not going to be fixed. All right, so the first reason was given back in October of last year when they officially notified me that this will not be fixed, they're not going to work on it. And I was given a second different reason several months later when I was interviewed for this by a threat post. So the first reason I was given was that it requires special functionality. However, it's not actually true. Everything that's being used as part of the HTML specification has been since at least 1998, and if not earlier. Second reason I was given for this no fix, and this was after the threat post story, was that it requires user interaction, which is partially true, but not fully true. So there are cases that require user interaction. Form submission, getting somebody to click on a link. Yes, the user does have to make that secondary request by themselves. However, we saw in case of iframe and frame elements and JavaScript redirects, that secondary request is automatically made by the browser without user interaction. So there's more. So I said that it would end after the endnotes, but it doesn't. So 3 weeks ago, I stumbled on another way to bypass the filter. Every so often, you'll run across a web application that performs not just single URL decoding, but double URL decoding. It's not nearly as often as the rest of the stuff I showed, but this is still something that you'll run into every so often. So, need to go to our intercepting proxy. So I have a hidden section on this page. Double URL decoding. So let me bring this up. So on this vulnerable website that I have up, and I'll give everyone the URL towards the end, after each of these pages is actually another file that has the actual PHP source that's running on the page. I also have a link to my GitHub that you can actually download this and run this on your own server if you don't trust mine. So what's happening is that there's a request, the XSS parameter is grabbed, this get operation performs the first URL decoding, and then we perform a second URL decoding that lands right on the page. So deliberately vulnerable. So I have this injection here that, as you can see, is double URL encoded. Our injection can not only do single URL decoding, but also double URL decoding. So what we can do is have an injection that is double URL encoded. Send that through. The filter does not catch it. It's a single request, and the injected JavaScript is executed. So again, in our intercepting proxy, there's just a single request where injection is double URL decoded by the server. Script source equals external JavaScript file, close script, bypasses the filter by itself. No need to do a secondary request with data from a primary request. So, and again, content security policy does not seem to work on Internet Explorer. So the URL for that website is up right now. That website will be up for the next week or so. So if you want to go there and poke around at it yourself. Also, my GitHub account where the PHP code is also hosted, so you can get that and run that on your own server, should you choose to do so. Again, it's deliberately vulnerable code, so don't have it running for long, unlike me, who's having it up for a week. Any questions?
I guess I should say, I'm a former facilitator, and I'm not employed by them right now, but I was. So I was wondering if you could compare and contrast Mozilla's response when reported in Firefox versus Microsoft's response.
So the question was about the differences between reporting this to Microsoft versus Mozilla. Firefox does not have a cross-site scripting filter, so there's nothing to report to. What I got from Microsoft was somewhat dismissive. I'm not sure if that's normal. This is the first time I've reported anything to them. I have not reported that double URL encoded stuff yet. I figure it's rare enough where it's not really that big of an issue. Any other questions? Some parameter, either a get. Okay, so the question was the actual context of how this works in terms of the page that's actually, in the end, executing the injection has to take code or some sort of input from a primary source somewhere else on the same domain. So it can be any parameter, either get or post. I just used get because that was easier to do. The concern then is, of course, being able to find some functionality that will do this as a post request, because you're actually looking for built-in functionality on the website that's already there most of the time, except in the case where we have the link back to the same page where that's just one page and I just inject my own division element that says, hey, click this link. So did I answer that? Okay. Any other questions? Thank you.